Okay, here's my video on my drawings. I wasn't originally going to make a video for this, but Mike kind of talked me into it. So here's one of my side view drawings, and go over some of the tools that I commonly use for drawing. First off, though, is the one you saw in the last video, triangle, basic triangle, works very well. Some of the other things, a caliper. Again, this does the, you can measure outer diameter, you can measure inner diameter, you can measure depth. 1,000,001 uses for this thing. I've used them for straight edges, like a makeshift straight edge. On the back, we have a inch to millimeter conversion and stuff like that, and real nice basic tool. This is again one of our standard tools that we have in the electronics shop. Some of the other things that I've collected over the years is different templates for electronics. We've got this one, and here's a PC board layout. And this makes drawing a lot easier. Here's one from about the 50s vintage, 1950s, 1960s. It's even got some tube stuff in it. And some more PC board layout. So these are all usually Bishop Graphics, or you can still get these online. They're pretty expensive now. They used to be dirt cheap back 20 years ago when everyone was using them, but I guess the price has gone up because no one uses these anymore. But anyways, here's the side view. So 6 inches overall, 0.15 inch thick cardboard, 1/4 inch spacing, 1 inch high on that guy, and the top view. So let me rotate this around so you can see it. And I use pen on mine. It's force of habit. Pen comes out when you're using the copy machine. When I use number 2 pencil, it usually doesn't come out in the copy machine. So this cuts force of habit. I always use pen on my drawings, so I can copy them and stuff like that. And that's another tool that I use a lot, is the copy machine. Just a regular basic old copy machine. It can do a lot of things, especially in electronics. You can make your schematics. You can make different revisions to your schematics very easily. You can do PC board layout and the tracks, and put that on a clear transparency, and use a photoresist method. Here's one of the boards for like a photoresist. If I open this up, I have this photoresist material. It's kind of like lithography for the old camera stuff back in the day. So it's like a green tint to it. If you expose it to UV, the stuff that does get exposed goes away. The stuff that is covered up stays. So that's basically how it works, and that's how you can make cheap PC board real easy, many copies with just a drawing and a copier to copy it over to transparency, and that's pretty much it. That's one of the little tricks that we do to do cheap boards. If you don't have a mill machine, or you don't want to spend money over and get them professionally done, you can do small lots PC boards on this type of photoresist method. It's the same thing as silk screening for like t-shirts and stuff like that. Same sort of process. And let's see, I'm gonna about the importance of drawings too. I know some people who still use primarily drawings for their schematics and their mechanical drawings, and that's because of 2 reasons. One reason is paper still is pretty good for archiving, believe it or not. If you look at CDs or thumb drives, these only have so many year retention to it, and paper beats them out all. I did a lot of research on that, on data storage back in my old company, and believe it or not, paper won out. So and the other thing is security too. There's when I used to work for a company that did a lot of DoD stuff, Department of Defense. It's a lot easier to, you know, lock a drawing up rather than have it on a computer that's open to a network and can be grabbed either with a virus or accidentally sent, or there's a million and one ways to lose information from a computer. So there's still a lot of companies that still do drawings out on paper because of usually those two reasons. Just for an example for archiving, let me show you this project over here. I had a project that I did about, I just did the drawings for about 10 years ago. So let me set up the camera tripod here. So it's been sitting on my shelf for around 10 years, and I still had all the drawings. Again, it was all on paper. Still looks as good as the day I drew them. And what it basically is here it is. This is actually a direction finding antenna. So this gets deployed. Like this, and your antenna radials come out, and it becomes basically a Yagi antenna, and you can do direction finding with it. So here's the drawings that I've did about 10 years ago. So it's been sitting around for that length of time, and I was able to duplicate it exactly because of the detailed drawings that I did. And here's some of the detailed stuff. Let's see, the assembly. So again, here we go, here's some more. So getting your drawings down, real important. Make sure you have all the details. That way you can reproduce whatever you want down the road. I even have some of my father's designs from 30-40 years ago that still, again, it's still on paper and it's good as when it was drawn. So here's some of the examples. I'm going to zoom in on that. So this is the top piece here. So you can see it. It's not exactly 1-to-1 scale, but you can see where I had to drill the holes. I have everything all nice and marked. So it's a pretty good example of detailed orientation and paper. Here's the element. And one of these days I'm going to get a video of this thing up and running. I haven't had enough time to do it yet. The direction finding. Basically it uses the Doppler effect to trace down RF signals. So, yeah, we use that in amateur radio. We call it fox hunting. Also the Coast Guard and the Civil Air Patrol uses a similar method with this, with ELTs, emergency location transmitters. They track down the ELTs with these type of devices too. But that's the main reason, the main thing between amateurs and them. We do it for fun. They have to do it as a job. So, so that's the example of a drawing to mechanical drawing to actual use, and that's pretty much it. See you later.